Hi, welcome to my channel about robotics, fischertechnik and embedded systems. This video is focused on my Arduino boards, being the 2560, Mega2560 Uno and all connected. This one with this one and this one with this one. Also a little bit of fischertechnik, and the focus of this series is data acquisition, performed by reading from this cable from the Mega2560 to my computer and then using languages like R, Python, Fortran and Octave to process the data. Of course Java to actually read the data from the board and C to program all the boards. But there's been some questions about the boards themselves, so let's take a look at that. And for that as well I changed to screencast. With the camera view and the source coder on the Mega2560, not 52. RStudio, and this is for the Fortran coder, Python coder, Octave coder, and that confused me last time because I had written a script for CSV and that was intended for Octave, but my focus has been shifted now. And then this is for Java, reading the actual coder or the data, then switching, which I actually need to correctly connect the boards together, and then hardware, electronics, some very light flashing here as well, and the motor. So why does this happen? And yes, you hear thunder. It's raining cats and dogs, or whatever you call it in English, pijpenstelen in Dutch. Anyway, very soft light burning here, and as soon as I engage the motor it's very bright. Why? Then two LEDs here, they're not doing a thing. I want to measure voltages, but I have only one functional multimeter here. And what do I do when I want to measure multiple points? Use the oscilloscope. So yes, it gives noise, but at least I can measure voltages on different points. So let me do that. And with a second camera pointed at the oscilloscope you can see the top yellow light, which is here. So moving this will obviously lower the voltage. Then I have one point here, which is the blue line. I have one here, which is the purple line, and I have a dark blue line. It's the bottom. That is the line that I actually will take for this one, which shows nothing right now. So it's a bit difficult to do so. I can better put it right here at the connection point, which shows right now absolutely no voltage. Now it does, and you can see the spikes when the motor is actually running. So that is a disturbance of the signal. Then I have two LEDs here. Why don't they burn? Are they alright anyway? So I have to be careful in measuring that. And now when I have all things together, including as you can see fritzing, I realize that fritzing isn't complete because these two LEDs are not even in fritzing. Not that it didn't matter, but it would be nice if everything is there. So now it's time to measure the voltage over these LEDs. And the first one I have to measure right here. And that is the lowest line, which indeed shows voltage. Then I have to measure somewhere here, which also shows voltage. and the fact that this LED doesn't do anything and this LED isn't doing anything that I can see anyway, indicates unfortunately that they may be broken. So what to do about it? Well, discard them. That's the only thing that I can do. Anyway, the wiring is correct. The signal is being given, considering everything that is happening. So let me once again put the probe here, and everything shows the signal. So once again a question, why is this motor not running? Yes, it is about 9 volts, but then again, with a little motivation, it does run, and then these LEDs start burning. So I haven't solved that yet. Can I solve it? That's another question. I'm not quite sure. And now that I'm measuring anyway, let's do other LEDs as well. Measuring them, that is, this one I have checked and it does work. This one is obviously working. I see it burn from the top of it. This one doesn't show anything, but regarding that, this one is working. At least let me just check it. Yeah, the lowest line is working. That's good. So this one has signal. This one does have signal visibly. What about this one? I'm not seeing any signal here. No signal whatsoever. Now there's a full signal, once in a while. Okay, so that may be that I programmed it to give just a signal once in a while. Let me probe and keep probing. And hopefully it does give a signal, and that signal has to come from here behind. Yeah, it did give a signal. So yeah, there's a signal, but I don't see the LED burn. So that may be 3 broken LEDs, unfortunately. The rest is functional, although the voltages are a limitation factor at 3.3 volts, but that's a problem. It's a minor issue, as well as that one. And it seems that this problem is directly related to this wire, which is coming from a digital signal, and this wire has problem, as you can see in the lowest line on the oscilloscope. So wiggling gives a high signal, which gives me doubt about the quality of the wire. If that improves for the LED, I'm not sure. I don't know. I don't think so. Anyway, that is for the electronics, and with for the data acquisition you do need reliable data. And as far as I've been measuring, some is reliable, others are less reliable. And with the data acquisition itself, that's going to be troublesome at best. And with that, let's return to the data acquisition part. Not this, and not this, but 1, 2, 3, 4. So it depends on the source code, obviously. on all the boards, and this one is just a 2560. Then it depends on the way you read with its problems. Then it depends on how you process it. Fortran, Octave with problem because it doesn't have a CSV file in here, but a CSW file, which is a mistake. But there's R, which does it reasonably well, and the Python, which does it reasonably well. But I will have to manually edit every file that is being written with the acquired data, which makes data acquisition, as far as I can tell from an Arduino board, cumbersome. So do I go on? I would like to, but I don't think so. Thank you for watching. If you like this video, please do subscribe to my channel, give the video a thumbs up, click the bell for notification, leave a comment or suggestion please under the video, and that's your oscilloscope in movement. You can also follow me via Twitter and Instagram, and you can support via PayPal, Ko-fi, and by becoming a patron. For more information, please see my website, which is listed under the video. And see you next time for another video. Have a great day, stay safe, take care, bye.